Okay, yeah, those are two really good questions. So first of all, he asked, how many planets will we be able to confirm? And it's a small number. To actually confirm with ground-based observations, doing Doppler spectroscopy or doing these transit timing variations, it's embarrassingly small because time on telescopes like the Keck 10 meter are so difficult to get. Our whole team of 50 some odd scientists is awarded 10 nights per semester on Keck. So we're right now in the process of trying to define the target list for this upcoming season of observing, and we're looking at like less than 100 stars that we're going to be observing. So, there's going to be a babbling brook, not a stream, not a flood of planet discoveries, maybe like a babbling brook. With that said, what we can do is, instead of confirm them, we can validate them. And so the idea is, okay, we can't confirm it in that we can't get a mass measurement. But what we can do is eliminate every other possible thing that it could be, right? That's a different type of an analysis. And what you're left with is, of all the different, you make a laundry list of every single astrophysical signal that it could possibly be, and you see how many you can eliminate. And if you eliminate 80% of them, then you've got an 80% likelihood that it's a bona fide planet and not something else. So every candidate will have this kind of a likelihood attached to it. And then we will add that up and see how many planets we got and correct and all of that to be able to drive our frequencies. But confirmations, it's going to be, I don't know, less than 100 probably within the next few years even. But all the data's out there for the whole entire astronomical community to look at. So our hope is that everybody puts their eyes on this data. Everybody that has an instrument capable of getting these kinds of precision measurements will help us to confirm them. Okay, atmospheres. So can we say anything about the atmosphere? One thing about Kepler 10b that I said, but I didn't explain in detail why we know. I said that just like the moon, Kepler 10b always presents one face towards its star. It's tidally locked, right? We know that from the data. Because if that's true, he will be my star. And I'm Kepler 10b, and you're my telescope. When I'm over here, you see my bright side, right? And as I walk around my star and I keep my bright side facing him, now you see the dark side, right? And so over that 0.84 day orbital period, I see a gradual increase in light and a gradual decrease in light. And so what I said before, that everything we know is from the star itself, is a little bit of a fib, because we see this, what we call a phase-modulated light from the planet itself as it undergoes phases. So that's the kind of thing that we can say with regards to the surface, or you said atmosphere. We can't really say anything about an atmosphere, but we can say something about surface temperatures. In some cases, we also can see the small dimming that happens when the planet tucks away behind the star. That's called an occultation. And that dimming, in order for that to happen, for you to see anything, the planet itself has to be kind of luminous. And that only happens in special cases, kind of like Kepler 10b, right, where you've got that one side that's very, very hot and therefore radiating. So when it tucks behind the star, there's potential to see a small dimming. And in our data, we see something, but it's really small. It's marginal. I didn't emphasize it in the paper because it's not yet a statistically significant result, but with time, I bet it will be.
But there's a certain reflection versus emission by the
That's right. Reflected light, seeing the same kind of thing due to reflected light, like if you think of the moon orbiting the Earth, right? You see different phases, so you would see the same thing if it's reflected light, and that's tougher. But if you've got a very high albedo planet, you might be able to see that too. It's something we'll look for. Yes?
How does it actually work? Is Kepler taking a whole bunch of pictures every day and just transmitting them back to Earth in this software that analyzes?
That's a good question. How does it work in practice? Exactly what is Kepler doing? It reads out numbers every 6 seconds and coadds them into 30-minute measurements. And it stores all of that data on board for a whole month. and then we dump it down to Earth once a month. The other distinction is that in our camera, there's about 100 million pixels. And as I said, there are 4.5 million stars, right? We don't observe all 4.5 million. We're not sending down every single pixel that our camera measures brightness with. What we did was we spent 4 years before we launched the spacecraft observing all 4.5 million stars, classifying them with regards to their surface temperature and gravity so we know what they are, and then cherry-picking those that are the best capable of yielding the detection of a small planet, if indeed it has one. So we cherry-picked about 150,000 stars. Those are the pixels that we send down, so it's a small fraction of the total array.